Alright, so now we're going to talk about Descartes' rule of signs, and what this does is it helps us figure out how many positive or negative roots you're going to have. So what it says is we're supposed to do is we're supposed to count the sign changes in P of positive and P of negative. Now, all that means is that I'm going to replace every x with a positive number, doesn't matter what positive number, and figure out whether that resulting term is going to be positive or negative. And then I'm going to do the same by replacing every single x with any negative number and figuring out whether each term results in a positive or a negative number. So let me walk you through this one. P of x equals x to the third minus x squared plus 1. Here's where I would encourage you to go ahead and write a coefficient for any negative term. You can even do it for any positive term, but especially the negative ones. And what I'm going to do is I'm going to take any positive number. I don't care what it is. I'm just going to put a positive number to the third power in place of my x. And then I have negative 1 times a positive number squared plus 1. Well, any positive number to the third power is going to give me a positive result. For this term, I have to do my exponent first. So a positive number squared will be positive times negative 1 makes that term negative. And my last one is a positive 1, so it's just plus. So what I want to do is count how many times my sign changed. From here to here, my sign changed. That is yes. From here to here, did my sign change? That is yes. So when I have two sign changes, that means that you are going to have 2 or 0 positive real roots. Okay? Whatever you get for your number of sign changes, you are going to decrease that by 2. Okay? Sometimes you will decrease it by 2 more than once. You will continue to decrease it by 2 until you get to 1 or 0. Okay? So I know that for this one, I'm going to have either 2 positives or I'm not going to have any positive real roots at all. Let's test P of negative. And let me recopy my P of x down here. So when I substitute in a negative number for x, a negative number cubed minus 1 times a negative number squared plus 1. Any negative number to the third power gives me another negative number. For this term, take a negative number and square it. You get positive. Times a negative 1 is going to make that term negative. And then the last one is a positive 1, so it's just a plus. So from here to here, did my signs change? No. From here to here, did my signs change? Yes. Since I have one sign change, I'm already at 1, so I'm not going to have to decrease this. I'm only going to have one negative real root. And the reason I need to know how many real roots we're going to have that are positive or negative is it will help me figure out whether to test positive or negative numbers using synthetic division. Alright, so now we are going to do a problem from beginning to end without a calculator at all. Once we're done, we may go back and look at it in the calculator and make sure it all matches up. but we're going to do it from beginning to end with no calculator. Okay, so here's the problem we're going to do. I've listed the steps for you, and then I'm going to write on notebook paper just because when there's this much work, I do better on lined paper. I keep it a little bit more organized, and I think it'll help you see it better. So let me get my problem copied. Alright, so step 1, we are supposed to list all possible rational roots. So what that means is I'm going to do the factors of my constant over the factors of the leading coefficient. And here, this being a -9 doesn't matter at all, because when I list my possibilities or my factors, I'm going to do plus or minus anyhow. So I'm going to start out with the factors of 9 on the top, which are plus or minus 1 times plus or minus 9, or I can do plus or minus 3 times itself. Then on the bottom, I have to put the factors of my leading coefficient. So the factors of 2 are plus or minus 1 and plus or minus 2. And now, each of the numbers on the top has to go over each of the numbers on the bottom. So I'm going to start out putting each of these over 1. So 1 over 1 gives me plus or minus 1. 9 over 1 gives me plus or minus 9. 3 over 1 will give me plus or minus 3. And now I have to go back and put each of these over 2. So when I put 1 over 2, I get plus or minus 1/2. 9 will give me plus or minus 9/2. And the 3 is going to give me plus or minus 3/2. So I have 2, 4, 6, 8, 10, 12 possible rational roots. So step 2 on our list was to use Descartes. Okay, so we're going to figure out whether we should test positive or negative numbers in our synthetic division. So let's start out with P of a positive number. Okay, so I'm going to have 2 times a positive number to the 4th power plus 3 times a positive number cubed minus 17 times a positive number squared minus 27 times a positive number minus 9. So when I do a positive number to the 4th power, I get a positive number, times 2 will give me a positive number. For the next term, a positive number to the 3rd power gives me a positive number, times 3 gives me another positive number. A positive number squared is positive, times negative 17 is going to make that term negative. A negative 27 times a positive number will give me a negative number, and then my 9 is negative. So let's count our sign changes. My sign does not change there. It changes here. It does not change here or here. So I only have one sign change. So what that means is that I am going to have one positive real rational root. Okay. I'm going to highlight that so that I remember it in a minute. Now I've got to test P of a negative number. So that is going to give me 2 times a negative number to the 4th power plus 3 times a negative number cubed minus 17 times a negative number squared minus 27 times a negative number minus 9. So, a negative number to the 4th power is going to be positive, times 2 is positive. A negative number to the 3rd power is going to be negative, times 3 will still be negative. A negative number squared is positive, times negative 17 is going to be negative. A negative number times a negative number gives me a positive number, and this is negative 9. So let's count our sign changes. Yes, the sign changes. No, it does not. Yes, it does. And yes, it does. So I have 1, 2, 3 sign changes. So what that means is I have 3 or 1. Remember, we decrease it by 2 until we get to 0 or 1. So I'm going to have 3 or 1 negative real rational roots. So now, step 3, I need to test those possibilities using synthetic division. Okay. So I'm going to recopy my P of X down here, just so you can all still see it. I'm also going to go ahead and list my possibilities again. These are the possible rational roots. They were plus or minus 1, plus or minus 9, plus or minus 3, plus or minus 1/2, 9/2, and 3/2. So I've got to decide what to test. Okay. The other thing to remember here is that we had one positive and 3 or 1 negative real rational roots. So I have to decide, do I want to start testing positive numbers or do I want to start testing negative numbers? Does not matter to me. What I do notice, and here's how I normally decide, is that I know I'm going to have one of each. For the negatives, I might have 3. So since I've got 6 negative options, and 3 of them might work, my odds are better when I test a negative number. So I'm going to start out testing a negative. So if we go ahead and test, we can start with -1. Put -1 in my box, and my coefficients and here's the thing, everybody, in the room may test a different number, and that's fine. It just means your work is not going to look the same as you go through the problem. You should all arrive at the same place, though. So I decided to test negatives because the odds were better of finding one. I picked -1 because it's the first negative number. So bring down my 2. Well, what do you know? We get lucky and -1 works. So when I get to here, remember I start out with x to the 4th, so this is going to be x to the 3rd, x squared, and an x. Now I need to test something else. I need to see if maybe another one of the negatives works, or if a positive is going to work. So let's go ahead and test another negative. How about we test, let's test 9 just because it's listed next. Okay, so if I test a -9, I'm going to use these coefficients for my depressed polynomial. So 2, 1, -18, and -9. So that's a 2. Ooh, and we got big numbers here. I've got to do -9 times -17. I have a feeling these numbers are going to be way outside the range I need. So that gives me a positive 153. So that combines to give me 135. Times -9 gives me -1,215, which will give me -1,224, which is not a remainder of 0. So -9 is not a root, so I've just got to ignore that. Back up a step and try again. So let's try another negative. When I try, let's do -3 this time. So -3, I'm going to use this same depressed polynomial here. Bring down my 2. And this time I get a remainder of 0. So this is a root. And now I have gone from x to the 3rd. This is going to be a 2x squared minus 5x minus 3. And at this point, I have a quadratic that I can solve by either factoring, maybe, or the quadratic formula, or I could try to complete the square. I think this one is factorable, so I'm going to factor it. If you want to do the quadratic formula, please feel free, go ahead. So to factor this, I'm going to use bottoms up. So I've got to multiply the 2 times the negative 3, x squared minus 5x minus 6. That will factor into x minus 6 times x plus 1. Remember to come back and divide by that 2. So I get x minus 3 and 2x plus 1 equals 0. Now set those factors equal to 0 and solve. So x equals 3 and x is going to equal negative 1/2. So when I'm listing all of the roots, I get x equals negative 1, negative 3, positive 3, and negative 1/2. And you can see here that I got 3 negative rational roots and I got 1 positive rational roots, which matches up with what we saw from using Descartes' rule of signs. Okay. Now, one more thing. I want to back up and show you that if we had been paying attention right back up here, when I had this polynomial, this cubic polynomial, I could have factored that using grouping. So what I want to do is I want to come out here and show you that, so that if you really don't like just guessing numbers to try to check them, as soon as you see something that's factorable, you can do it from there and get the same results. So for my 2x cubed plus x squared minus 18x minus 9, I can group these by putting these two together and then these two together. So for the ones in my yellow box, my GCF is x squared, and that will leave me with 2x plus 1. In my pink box, my GCF is negative 9, and that will leave me with 2x plus 1. So I pull my common parenthesis out front. My leftovers are x squared and minus 9. So at this point, I can set my factors equal to 0 and solve. And I still get the same answers, 1, negative 1/2, and a positive and negative 3. So a couple of different ways of getting to the same place. You just have to figure out what works for you, and it may be different every time.